Hi everyone, this is Mrs. Musoff here. Today we're going to kind of run through the notes for 2.1 Day 2, which is talking about average versus instantaneous rate of change. Now, hopefully average rate of change sounds somewhat familiar. We talked about it way at the beginning of this class, so first semester. Average rate of change, average speed, right? It's just the change in y over the change in x. Or this is the formula that you might look familiar. F of x minus f of c divided by x minus c. For average speed, we're really still using this same idea. The formula that sometimes you'll see just could look a little different, but either one of these formulas is really totally acceptable. But when we start talking about instantaneous speed, that's when you're going to really need to understand this formula here. And notice this formula is really the same idea. All right, just instead of using two completely different x values, right, x and c, we really just use t as kind of the starting time, and then h as that extra time that's after t. So we call it the plus h is like the elapsed time. So for example, if I start at, time 0 and then 5 seconds have elapsed, that means h would be 5. And so the reason the denominator is just h is because technically you're doing t plus h minus t, which would just give you h. Okay, so really same general formula, but eventually when we start talking about instantaneous rate of change, this is the formula that we're going to want to use. Okay, so to give you a quick reminder of how average speed works, that's what this first example is. A water balloon dropped from a window. A water balloon, it should say, is dropped from a window and falls according to y equals 4.9 t squared meters in t seconds. Find the average speed during the first 3 seconds. So first 3 seconds, that's like we're using t equals 0 to t equals 3. Or if it's helpful, you could just imagine the elapsed time would be 3 seconds. Right? So t would be 0, right? And then the h, the elapsed time, would be 3. But either way, average speed, right, whenever you see it's asking for average speed, that should just be the change in y over the change in x, which is like the distance over time, right? So I would calculate my y value at 3 seconds, calculate my y value at 0 seconds, and that would be the numerator. Subtract them, right? The difference, the change in the y values. And then the denominator would be the change in the x values. So from 0 seconds to 3 seconds, that would be 3 minus 0, which is just 3. And if you calculate that, you would end up with 14.7. Just need to remember units. Speed is distance over time, so in this case that's meters per second. Okay. Instantaneous speed is going to be the new part of today, because instantaneous speed is speed at a specific instant of time. So not over the course of 5 seconds or 10 seconds, but at one exact second we want to know the speed. And so the idea of instantaneous speed is that the elapsed time should be 0. Right? Because we just want at one exact second. Well, how would we calculate it if the elapsed time is 0? Then we'd be dividing by 0 in this equation, and we know we can't do that. So what we do is we keep the elapsed time as a variable, our variable h, and instead we find the limit as h approaches 0. That way we are approaching an elapsed time of 0, which would be a specific instant or one specific second of time. Okay. So using the same example as above, now we're going to try and calculate the speed at the instant t equals 3 seconds. So for these problems, it's going to be really important that we use this formula here. And so just recognize that h, our elapsed time, when we're dealing with instantaneous speed, we're going to keep h as a variable. We're going to keep it as h. And then after we've kind of plugged in our specific instant of time, we're going to calculate the limit as h approaches 0. All right, so that's what we've got some work showing here. All right, so again, find the speed at the instant t equals 3 seconds. Speed is still change in y over change in x, right? Change in distance over change in time. But here, since it's one exact instant, t, my time, is 3 seconds, and h, my elapsed time, is going to be a variable. And once I've calculated this formula, I'm going to be calculating the limit as h approaches 0. So all I did is I substituted 3 in for t. Alright, that means I'm plugging in 3 plus h into the formula at the top, which is, let me get it shown there, which is y equals 4.9 t squared, right? Still using that formula. All right, so I'm substituting 3 plus h in for t, and then in the second piece, I'm substituting 3 in for t. So in the numerator, I'm just simplifying, right? I have to expand out 3 plus h squared, so distribute. All right, once I've distributed, you should notice certain terms can subtract and give us 0. So right here, 44.1 minus 44.1. Okay. Now, it's from this point where you have to be very clear in your steps. I know some of us like to kind of jump to the end when we see what's going to happen, but with these problems, we really need to see every single step so that we can recognize how you eliminated variables. And so I really want to see these 3 steps very clearly, and that is when you're left with just terms with h in the numerator and we're dividing by h, I want to see that you factored h out, and that's how you were able to simplify the h away. Okay, so these steps here, this one, 1, 2, and 3, I want to see those steps very, very clearly. Once you've simplified the expression, now in order to actually find the instantaneous speed, we're going to calculate the limit. So I'm going to be finding the limit as h approaches 0 of this expression. Well, the great thing is, since this expression is a polynomial, I know that I can just use substitution to calculate that limit. So in order to calculate the limit, I substitute 0 in for h. That allows me to get rid of the limit, and then evaluate. All right, and once I've evaluated, I've found my instantaneous speed. All right, so for instantaneous speed, the main idea is to recognize that you want to use this formula here. But instead, we're going to use that formula with a limit. So technically what you're calculating, sorry, let me write it out right here, is the limit as h approaches 0 of f of t plus h minus f of t divided by h. This right here is the formula we're using for instantaneous speed. Okay, and you can see over here I try to draw a little graph just to show you exactly what we're calculating. If this is at t equals 3 seconds, this is like 3 plus however many seconds. The idea is we're getting this point closer and closer and closer to 3 so that I'm really just focused on the speed right at 3 seconds. And the speed is actually kind of the slope of the tangent line, but we'll talk more about that later. All right, on the back of my notes, I just wrote those steps out again just because I know it got kind of squished in there, and so I wanted you to be able to see it a little clearer. So just in case you need it, feel free to take a look. But it's really the exact same steps as right here, just written out with more space. All right. If you have questions on average or instantaneous speed, be sure to write them down. Otherwise, go ahead and try some of those problems, and thanks for tuning in.